Hello students, myself Javeer Singh, Senior Lecturer, Government Polytechnic College for Girls, Amritsar. So in this session of EduSat lecture, we will study the programming of microprocessors. So first of all, introduction about our today's discussion. A microprocessor is an integrated circuit in which all the circuits required to perform the function of a CPU are fabricated. So that IC chip is called as the microprocessor. And microprocessor is a programmable device. So by saying the programmable device, we mean that microprocessor can do what the programmer asks it to do. So, to perform a particular task within the capability of a microprocessor, the programmer prepares a sequence of instructions called a program. Now, these sequence of instruction, which is called a program, is stored in the RAM, that is random access memory of the system. Then after that, the CPU takes one instruction of the program at a time from the RAM and then executes it. It executes all the instructions of the program one by one to produce the desired result. Now, in this slide, I will explain you the program execution sequence, and we will concentrate our discussion with respect to 8085 microprocessor that is in the curriculum of our syllabus of 4th semester. Now, in this slide, I have explained the program execution sequence. The program is stored in sequential memory locations, that is memory location one by one in the sequential manner. The basic steps followed by the microprocessor to execute a program which every student must understand are fetch, decode and execute. So, first of all, we will discuss the first step, that is the fetching operation. Fetching means to get the operation codes or instruction codes from the memory to the microprocessor. That is the various steps taken by the microprocessor to fetch the operation codes or data stored in the memory to the microprocessor. Now, this is how this is done. First of all, the address of the memory location that is stored in the program counter is placed on the address bus, and in the first T state of the machine cycle, a ALE signal, that is address latch enable signal, is generated, and low order address bus is latched in an external latch. Due to this, now lower address lines can be used as data lines now, and due to this 16-bit address which is sent on the address bus, any one of the memory location out of the total memory is selected where we have stored our program or where we have stored our instruction. Now, with the help after that, in the meantime, microprocessor also generates input output oblique memory signal to enable a memory signal and read signal to enable that particular memory location which has been selected. And with the help of these signals, the data which is stored in the selected memory location is placed on the data bus, and from there it goes into the instruction register inside the microprocessor. Now, this operation which I have explained completes the fetch operation of the program execution sequence. Fetching means to get data from the memory into the instruction register, and microprocessor for this purpose places the address. Where is the address? Address is in the program counter. That is, contents of the program counter are placed on the address bus, and necessary signals are generated like ALE signal, IO oblique memory signal, and read signal are generated. Low order address lines are latched, and the same lines are used as the data lines after that. And after read and write signal, the data from the memory location fetched and stored in the instruction register inside the microprocessor. This completes our fetching operation. Now, after that, next operation is the decoding of the fetched data or fetched code. Now, decoding means microprocessor has a particular meaning for every 0 and 1 combination or data combination it receives. So, it is designed to perform according to the codes which is given to the microprocessor. Now, the data which is fetched and stored in the instruction register, from the instruction register it goes into the instruction decoder. Instruction decoder decodes that 0-1 combination fetched by the microprocessor from the memory, and then after the decoding it generates the necessary timing and control signals to complete that execution. So, third part of the sequence of program execution is the execution, that is, the fetched data is decoded in the instruction decoder, and then timing and control unit generates necessary timing and control signals to complete the execution of the given instruction. Now, this sequence is repeated until the point when the last instruction in the program fetched by the microprocessor, and it has stopped the further incrementation of program counter to fetch the data from the next state. So, we must understand a microprocessor works on these three principles, that is fetching, decoding and execution, and fetching is done with the help of the contents of the program counter. When the current operation code is being fetched, the contents of program counter are automatically incremented to point out to the next memory location from where the next opcode is to be fetched. So, by doing this operation, the microprocessor completes the program execution sequence. So, I hope all of you understood the program execution sequence, that is fetching of the opcodes from the memory, then decoding it with the help of instruction decoder, and executing with the by generating the necessary timing and control unit by the timing and control unit inside the microprocessor. Before we start the programming principles, we must understand what is a machine language program and what is an assembly language program. Now, a computer uses binary digits for its operation and understands information composed of only zeros and ones. That means, microprocessor cannot understand a English like words, but it can only understand binary digits, that is a voltage level high or a voltage level low, that is called as a 0 or ones. Now, a program written in the form of zeros and ones is called a machine language program. So, any program which we write after the assembly, that is called as the machine language program. In machine language, there is a specific binary code for each instruction. Now, if we talk about 8085 microprocessor, it is an 8-bit microprocessor. So, total number of instruction in the instruction set of microprocessor can be 256, but we have in microprocessor 244 instructions available to us, and there are 74 operation codes. So, for each instruction, microprocessor has a different machine code or combination of zeros and one, and a program written in the zeros and one form is called as the machine language program. Now, what are the demerits of writing a program in a machine language? So, it is very difficult to understand or debug a program. You see, when we write a program in zeros and ones, it will be very difficult for us to understand or a debug program which is even written by us, and in case it is written by some other programmer, it becomes very difficult, because it is not easy to memorize or every 0 and 1 combination at as an instruction. Since each bit has to be entered individually, the entry of a program is slow, and these programs are long as well. The program writing is difficult and tiresome, and chances of careless error in writing a program are very high. Means sometimes you enter a 1 instead of a 0 or a 0 instead of a 1, the whole program will get wrong, and it is very difficult to debug that program, and chances of careless error, that means, are very high in writing a program in the machine language. So, what do we do then? We, in that case, we do a assembly language program. What is assembly language? In this, we use English like words called as the mnemonics. Mnemonics is a Greek word which meaning memory aid, which helps a program written in assembly language or mnemonics is very easy to understand and debug as well. So, the advantages are like this: the writing of program in machine language is very difficult, tiresome, boring and error prone, as we have discussed in the previous slide. A program can easily write a program in alphanumeric symbols instead of zeros and ones. So, as a programmer, I can write a program in alphanumeric symbols, that is mnemonics. These English like words for every code or every operation which is to be performed by the microprocessor, that is called as the mnemonics. So, meaningful and easily rememberable symbols are chosen for the purpose. For example, we can use ADD, that is add for addition. For subtraction, we can use SUB, that is sub for subtraction, and CMP for comparison. So, from these words we get an idea about the operation to be performed by the microprocessor, and these English like words or such symbols are called the mnemonics, and a program written in the mnemonics is called as the assembly language program. So, a program written in the mnemonics is known as the assembly language program. The writing of a program in assembly language is much faster and easier as compared to writing of program in the machine language. So, it is also known as a low level language. Why it is called as low level language? Because it is microprocessor specific. It is particular for each type of microprocessor. 8085 has its own mnemonics and its assembly language. Other microprocessor will have their mnemonics and assembly language. So, it is, that's why it is called as the low level language. It can't be like that one assembly language program can be run on the microprocessor which is of some other number or other type. So, the program written in mnemonics is called as the assembly language program. So, also before we start with the actual programming, one must understand the valid addressing modes of the microprocessor. So, all of you first of all understand that any instruction, what is an instruction? Instruction means a meaningful command to the microprocessor to perform some function or operation within its capability. So, instruction is a command to the microprocessor which it can understand and perform some operation which is programmed to or designed to do according to that machine codes. So, any instruction or a command is made up of two parts. One part of the instruction is the opcode and other part of the instruction is the operand. Now, first part of the instruction is the opcode. What do we mean by opcode? Opcode is that part of instruction which gives information about the operation to be performed. Like we want to do addition, or we want to just copy your data, transfer from one place to another, or we want to do some subtraction, or we want to change the sequence of execution like branching instruction, or I want to do some arithmetic or logical operations. So, that information, what this instruction is going to do is that information is contained in the instruction, that is the first part of the instruction, and that part is called as the opcode. Now, only opcode is not sufficient information. We must know the data upon which that operation is to be performed. So, that part of the instruction which gives, it must be specified in the instruction itself that we want to do this operation, and on this data we want to do this operation. So, operand is the part of the instruction which gives the information about data upon which given operation is to be performed. So, upon the data upon which the operation is to be performed, that part of instruction which is giving us the information regarding the operand is called as the operand. Now, for all microprocessor, there are various ways to specify operand in an instructions. There are valid ways. You can't just mention an operand in an instruction, but for every microprocessor, we have some valid ways to how to specify an operand in an instruction. So, the way by which operand is mentioned in an instruction, the valid way by which operand we have mentioned the operand in an instruction is known as its addressing modes. So, I repeat once again, what do we mean by addressing mode? Instruction is a command to the microprocessor to perform some function within its capability, and there are two parts of the instruction. One is opcode, that is the part which is giving the information about the operation to be performed, and the other part of the instruction is the operand, which is giving the information about the data upon which that operation is to be performed. So, there are ways by which we mention, there are valid ways. We can't go beyond or above or anywhere against those valid ways. So, the valid way by which we mention an operand in an instruction is known as its addressing modes. Now, in this semester in our curriculum, we are studying the 8085 microprocessor. So, in this slide I am more concentrating about the addressing modes of the 8085 microprocessor. There are 5 addressing modes for 8085 microprocessor. One is immediate addressing, second is register addressing, third is direct addressing, then register indirect addressing and implicit addressing. Addressing means at any instant of time, the data or the operand, we both have the same meaning. We can call it a data or we can call it a operand. So, it has three destinations, three sources, sorry. It can be in some internal register. As all of you know, there are 6 general purpose registers, namely register B, C, D, E, H and L, and an accumulator which can be also considered as the part of arithmetic and logical unit, and all of these internal registers or general purpose registers are accessible to the programmer with the help of instruction. That means, a programmer can access these registers and store data and modify the contents of these registers with the help of instructions. Now, data at any instant or in any instruction can be there in some internal register, or it can be stored in some memory location, or it can be given immediately in the instruction itself with the opcode. So, depending upon how we can mention data in the instruction, the 5 addressing modes had been specified in case of 8085 microprocessor. These are immediate addressing, register addressing, direct addressing, register indirect addressing, and implicit addressing. As we know, the data can be either in the internal register, it can be either in the memory location, or it can be either given directly in the immediately in the instruction. So, first of all, we have immediate addressing. In this addressing mode, the operand is specified within the instruction itself. It's neither it is in the internal register nor it is in the memory, but it is in the mentioned in the instruction itself. Examples for this type of addressing. So, it is a valid way of mentioning a data. So, for examples for this type of addressing is MVI A, 05H. Now, here we want to store a data 8-bit data into the accumulator, that is internal register. This is the most important internal register, the data is 05. So, here the data which is to be stored given immediately in the instruction. So, this type of representing data in an instruction or mentioning the data in the instruction is called as the immediate addressing. Next example in the for this addressing mode, that is immediate addressing mode, is ADI 06H. This instruction means we want to add 06 or any other 8-bit data in the with the add these data with the contents of accumulator and want to store the result in the accumulator itself. So, here also one data which is in arithmetic instructions is usually in the accumulator, and the other data it is neither it is in the internal register nor in the memory location, but it is given in the instruction itself. So, when the operand is given in the instruction itself, this type of mentioning of operand in an instruction is called as the immediate addressing. Next, we have register addressing. Now, in register addressing mode, the operands are in the general purpose register. As I have mentioned earlier during my lecture, and hope my students also know this thing, that there are 6 general purpose registers and 1 accumulator. These general purpose registers are A is for accumulator, B, C, D, E, H and L. When we have already stored data in these general purpose registers and accumulator, and instead of giving the data, we are mentioning the name of that register in which the data is already stored. This type of mentioning the operands in an instruction is called as the register addressing. The examples for this type of addressing are given here, like move AB. In this instruction, we are copying the data from the register B into register A. We do not know what is the data, but we are mentioning here the source and destination where the data is to be copied and stored. Source is here B and destination is here A. So, this type of mentioning an operand in the instruction is called the register addressing. In this type, we have not mentioned any data, but we have mentioned the name of the register in which data is stored. The other instruction in this type of addressing is add B. Add B means add the contents of register B into the register A and store the result in the register A. So, this type also we haven't mentioned here the actual data, but we have mentioned the name of the register in which the data is stored, that is register B, and register A is here implicit, because in arithmetic instruction one data has to be there in the accumulator, and after the operation the result is to be stored in the accumulator itself. Now, in first two cases, that is immediate addressing and register addressing. In first case, the data was given immediately in the instruction. In the second case, it was in the some internal register, and name of that register was mentioned in the instruction. Now, in third type of addressing, that is the direct addressing. As the data can either be immediate, or it can be in the internal register, or it can be stored in a memory location. Now, in case the data is stored in the memory location, what do we need? We need the 16-bit address of the memory location where data is stored. And if we write an instruction in which we have mentioned the address of the memory location where data is stored instead of the data, or instead of the name of the register or immediate, in that type, this type of mentioning data in the instruction is called as the direct addressing. Now, if we see the example here, the instruction STA2400H, here we have given 16-bit address, that is 2400. This 16-bit address is not data, but it is the address of the memory location from where the data is stored from the accumulator. Here source is accumulator and destination is the memory location where we want to store the data what is stored in the accumulator. So, 2400 is the address of the memory location. So, in this type of addressing mode, we have mentioned the address of the memory location, and I want to store or load data from the memory location. So, when the data is in the memory location and address of the memory location is given in the instruction, this type of addressing mode is called as the direct addressing mode. Next instruction example for this type of addressing is IN02H. This is a IO instruction. So, 8-bit address is given here, because in 8085 microprocessor we can have only 256 input output devices in case we use in and out instruction for copying or sending data from an peripheral device. So, here 8-bit address 02 is the port address, and we want to copy that data from this port into the accumulator. So, this type of addressing in which the address of the memory location or a peripheral device is given and data is stored there, this type of addressing, when direct address is given in the instruction, is called as the direct addressing. Next addressing in case of 8085, which is a valid addressing mode, is a register indirect addressing. Now, in this type of addressing also the data is stored in the memory, but address of that memory is not given in the instruction. Rather, we have mentioned M in the instruction. M means the address of the memory location is stored in some register pair, and the default register pair in case of 8085 microprocessor for this purpose for register indirect addressing is the HL pair, because we can have 3 register pairs in case of 8085 microprocessor. We have 6 general purpose register like B, C, D, E, H and L, and out of these 6 general purpose registers we can make pairs like B can be combined with C, D can be combined with E, and H can be combined with L to make a BC pair, DE pair and HL pair. And whenever we refer a pair, we write only first register name for that particular pair. Like for example, if I refer to a BC pair, so I will only write B. Like in the example given here, I have written instruction LXIH 2500H. This is an immediate addressing mode, and I have, with the help of this instruction, I will load 2500 in HL pair. And if you see the instruction, I have not mentioned HL, but I have mentioned only H, because first register is mentioned in case we use it as a pair. So, for referring to the HL pair, I will only write H. So, this first instruction in the given example LXI H2500H will load the HL pair with the data 25 and 00. That means H will have 25 and L will have 00 data after this instruction. Now, next instruction, that is move AM. This belongs to register indirect addressing. Now, with the help of this instruction, I want to copy the contents of memory location whose address is already stored in the register pair HL. So, what is there in the HL pair? In HL pair, I have stored 2500 with the help of LXIH instruction. So, when there is 2500 in the HL pair, and by writing the instruction move AM, I will copy the contents of memory location 2500 into the accumulator. So, when the data is in the memory and address of that memory is in some register pair, and that pair will be HL pair in